Okay, hi everyone. In this video, I'll be going through the YTSS EOY 2022 A Math paper. So make sure you have completed it first before watching this video to see how I work through each question. Okay, so let's start. Let's look at question 1. Question 1. Find the range of values of k for which this equation here has no real roots. So if you recall what you have learned in the equations and in the quadratic functions chapter, anything with no real roots, if an equation has no real roots, the implication is that the discriminant d is strictly less than 0. Okay, so with that, I can now obtain my discriminant from this quadratic equation over here. So we can do this by writing very clearly over here. Based on this equation here, we can see that usually the general form for any quadratic equation is ax squared plus bx plus c. So in this case, we can identify my a to be equals to k minus 12. My b, which is the coefficient of my x term, is 2k. And c is in this case negative 1, not just 1, but it encompasses the sign over here. Okay, negative 1. So therefore, the discriminant in this case, discriminant of this quadratic equation, if recall, discriminant is equal to b squared minus 4ac, and therefore, this discriminant is equal to b squared is 2k the whole thing square minus 4, a is k minus 12, c is negative 1, and therefore I expand everything. This will be 4k squared plus 4 plus 4k minus away 48. Okay, so I'll get this quadratic expression here. And since they say that this equation has no real roots, so therefore, since, in this case, since for no real root, the equivalent statement is that the discriminant is less than 0, I can therefore write 4k squared plus 4k minus away 48 is strictly less than 0. Okay, and therefore I can now simplify this inequality. I notice that all these numbers here, 4, 4, and 48, are divisible by 4. So by doing that, I can make this inequality easier to solve. I divide the whole equation by 4. I'll get k squared plus k minus away 12 less than 0. Then from here is solving my inequality. And if you recall, how to solve inequality is that I first factorize this entire expression on the left-hand side first. By factorization, I'll get k plus 4, k minus 3, less than 0. Then from here, how to solve? So if in case you have forgotten, what I'll do is that, given this quadratic expression here, I can draw a simple working. This is simply a smiley face function. I can draw a smiley face over here. Okay, and I draw a line over here. And from this factorized form, I can see that the factors, the intersections are negative 4 and 3. And I want the part of the graph that is below the x-axis, which means that my solution should be this case over here. So therefore, the final answer to this question is simply k is strictly between negative 4 and 3. And this is my solution for question 1. Okay, next move on. Question 2. Question 2, sketch on the same axis below an exponential function and a ln function. So if you recall, for any exponential function, let me write the side, y equals to 2ex. The general shape for any exponential function, okay, is always, let me extend this line here. Okay, the general shape for any exponential function, it always looks something like this. Okay, but in this case over here, I need to find out what exactly is my y-intercept. So over here, to find out a y-intercept, simply for y-intercept, I'll sub x to be equals to 0. So therefore, y will be equals to 2e power 0, which will be 2, which tells me that in this case, for this equation here, when I sketch this exponential function, the y-intercept is 2. And the same thing, we can do the same thing to analyze my y equals to ln x over 2 function. If we recall the general shape for any ln function, if I do another simple sketch, it looks something like this. Y, x. Any ln function always looks something like this. Okay, the graph doesn't touch your y-axis, so we need to find out what is my x-intercept. In order to find out what is my x-intercept, for x-intercept, what I'll simply do is to sub y to be equals to 0. So therefore, ln x over 2 equals to 0. Therefore, x over 2 is equal to e power 0, which is equal to 1. Therefore, x is equal to 2. So I know that in this case over here, my x-intercept is 2. In this case of the exponential function, my y-intercept is 2. So given this point 2 over here, any sketch you must always label your important axial intercepts. I know that this point is 2. This point here is 2 on the x and y axis. Therefore, I can now sketch my graph. So for my ln function, my graph will simply look like this. Yeah, something like this. Okay, it should intersect at 2. Okay. Okay, this one is a bit. Okay. It should be a bit curved lah. I don't know why this is like that. Yeah. Then this is my ln function. I label this as y equals to ln x over 2. Okay. And in this case, for my exponential function, I can also sketch my graph. I should get a curve that looks like this, whereby I intersect at the y-axis where it is at a value of 2. And I label this y equals to 2e power x. And that is the solution to the sketch. Okay. And the next one, state the range of values of x for which the ln function is defined. We know that for any ln function to be defined, this number here must always be strictly positive. So therefore, I know that x over 2 must be strictly positive. Therefore, x must be strictly more than 0. Okay, so this is the solution to question 2. Alright, so now let's move on to question 3. Okay, question 3, express this quadratic expression in the form of a bracket x plus b squared plus c. One look, we can see that this is the completed square form. So therefore, you're expected to apply your completing the square skills in order to turn this quadratic expression into this completed square form. So express this first, then hence use this to explain this part, which will explain why this quadratic expression is always positive. So let's start by turning this quadratic expression here first into the completed square form. Okay, so 2x squared minus 6x plus 13. We know that the coefficient of your x squared must always be 1. So I first start by simply factorizing 2 out from, let's say, x squared minus 3x plus 13 over 2. Okay, then next I simply apply x squared minus 3x plus b over 2 squared, negative 3 over 2 squared, minus away, the same thing. Then I have plus 13 over 2. Okay, I should put a square bracket because I already have a bracket inside here. Square bracket, square. Okay, therefore, this will become x minus 3 over 2 square. Then I can simplify this even further. So over here, negative 3 over 2 square, I will get negative 9 over 4 plus 13 over 2. Then from here, I can simplify even further first. X minus 3 over 2 square. Then negative 9 over 4 plus 13 over 2. I will get plus 17 over... calculate correctly. 13 over 2 plus 13 over 2, 17 over 4. Yes, 17 over 4. Okay, then from here I simply remember a common mistake is that I need to multiply this 2 in. Many people always multiply just this 2 to this term, whereas you need to multiply this 2 to the first term here as well as the second term over here. So therefore we will get 2 times x minus 3 over 2 the whole thing square plus 17 over 2. And that is my answer for the completed square form. Okay, so therefore the next part, hence explain why this expression is always positive for all real values of x, meaning that explain why this completed square form here is always positive. So as we know, any square number or any square function is always greater than or equal to 0. So therefore I know that, let's start by what we know first. We know that this anything square, okay, since x minus 3 over 2 square is always strictly greater than or equal to 0, okay, if I multiply a 2 to both sides of this inequality, 2 times x minus 3 over 2 the whole thing square is still greater than or equal to 0. And if I add 17 over 2, okay, if I add 17 over 2, 3 over 2 to both sides of the equation, you can see that this expression here is always strictly more than 17 over 2, strictly greater than or equal to 17 over 2, which tells us that it is always strictly more than 0, which is always positive. So therefore, we can conclude that this expression here, 2x minus 3 over 2 square plus 17 over 2 is always positive. Okay, it is important to show these inequality steps to show very clearly that when I add 17 over 2 is greater than or equal to 17 over 2, which is strictly positive, which is what the question wants us to find. Okay, the reason why you cannot just say that this inequality sign is because always positive, 0 is neither positive or negative. So it is insufficient to conclude with this inequality. You need a strictly greater than 0 to answer the question. Okay, so this is for question 3. Alright, so let's move on to question 4. Question 4, the line is a tangent to the curve. Tangent to the curve, so that means that if I have a simple curve, for example, this is smiley face graph, I have a line that is simply a tangent to a curve, meaning that tangent to the curve, one intersection point. Okay, and we know that from what you have learned under discriminant, one intersection point means your discriminant must be equals to 0. Okay, so you remember, in order to find this tangent and curve intersection, we must equate the two equations together. So over here, what I can do is that I will sub this equation. Sub equation of curve into line. So given that the equation of curve is this equation here and the equation of the line is this, in order to find intersection points, I must equate the curve and line together. So since y is equal to this expression here and I have a y under the line equation here, therefore 2x plus, instead of y I can rewrite it to be x squared minus mx plus 7 equals to 6. Then from here I can simplify this quadratic equation. X squared, I combine all the x like terms with x over here, which is 2x and minus mx. This will become plus 2x minus mx. Then 7, I bring over the 6, it will be plus 1 equals to 0. I can simplify this even further by factorizing out the x, which are like terms. X squared plus 2 minus m x plus 1 equals to 0. Okay, and now the condition for the question is that this line is a tangent to the curve, which means that the resulting quadratic equation, which is this quadratic equation over here, the discriminant must be equals to 0 in order for there to be one intersection point. So very simply, in order to not make at least any careless mistakes, I always like to identify my A, B, C first. In this case, A is the coefficient of your x squared, which is 1. B is coefficient of your x, which is 2 minus m. C is your 1 in this case. So therefore, discriminant, which in this case is equal to, is always b squared minus 4ac. I can sub in 2 minus m, the whole thing square, minus 4 times 1 times 1. And then you can simplify everything by expanding this bracket. 4 minus 4m plus m square minus 4. I'll have m square minus 4m. Okay, and I know that since discriminant must be equal to 0, this tells us that m square minus 4m must be equal to 0. To solve this equation, simply do factorization. You cannot cancel out m because m can be equal to 0. So by factorization, if you cancel, you are removing one solution. This will become m minus 4 equals to 0. Therefore, by my zero product rule, m equals to 0 or m equals to 4. Okay, just one point to highlight over here. Cannot cancel m. What many people will do is simply from here you'll get m minus 4 equals to 0. Okay, this step is wrong. You are removing one solution whereby x is equal to, whereby m is equal to 0. Okay? Yep, so that is the solution for question 4. Okay, so now let's move on to question 5. Question 5, the speed of an electric car is given by this expression here. Time taken for electric car to cover a distance of, this is this expression here. Find the value of P and Q. Okay, so over here we must first recall our speed formula first. We know that you learned this in primary school as well. Speed equals to distance traveled over time. Okay, in this case over here, I want to find the time taken, which is this P plus Q root 5. So therefore, time taken is simply your distance divided by speed. Okay, so therefore, in this case over here, the distance I know is 10 minus 3 root 5 over speed, which is 2 plus root 5. Okay, so very simply, how to simplify this fraction? We see a cert in the denominator, you can rationalize it by multiplying the conjugate cert times 2 minus root 5 over 2 minus root 5. Okay, then we can simplify from here. Okay, so over here my numerator will become 20 minus 6 root 5 minus root 5 times 10 minus 10 root 5 plus 3 times 5. Okay, then my denominator is a plus b times a minus b. I'll get a squared minus b squared, which is 4 minus 5. Simplify everything from here. My numerator will give me 20 plus 15, 35, minus 16 root 5. The whole thing divided by negative 1. Answer is negative 35 plus 16 root 5. Okay, so therefore over here I can say that find the value of P and Q. So you must state an answer statement. Therefore, by comparison, P is equal to negative 35, Q is equal to 16. Okay, and that is my answer to question 5. Alright, so now let's look at question 6. Question 6, given the curve and line intersect at 2 points, always remember, in order to find curve and line intersection, what I'll always do is to try to equate these two equations together. So over here, I know the line. Equation of the line is simply x equals to 2y. based on this equation over here, I cross multiply, I can get from the equation of line to be x equals to 2y. Therefore, sub equation of line into curve to find intersection point. So therefore, all the x I replace by 2y. Instead of this equation over here, I will have 2y square plus 2 times 2y times y minus 2y equals to 3. So I just expand and simplify. I will get 4y square plus 4y square minus 2y equals to 3. Simplify everything, then I shift, make the right hand side equals to 0. I'll get 8y square minus 2y minus 3 equals to 0. Okay, then from here, I have a quadratic equation in y. Simply how to solve a quadratic equation, there's always two ways. Either you factorize or you use a quadratic formula. An easier way here is to simply factorize. So if I factorize this, I'll get 2y plus 1 times 4y minus 3 equals to 0. So therefore, 2y plus 1 equals to 0, or 4y minus 3 equals to 0. Therefore, y equals to negative half, or y equals to 3 over 4. But always remember from here, your question asks you to find the coordinates. Coordinates meaning that your answer should be in the form of x, comma y. So over here, once I find the y coordinate of the point intersection, I just need to sub this back into the original equation of the line in order to find the x coordinate. So when y equals to negative half, x is simply 2 times y. 2 times negative half, which will give me equals to negative 1. Okay, and in this case over here, when y equals to negative 3 over 4, x equals to 2 times 3 over 4, which will give me 3 over 2. So I have the two coordinates of the point of intersection, here and here. Now the question says, find the coordinates of m and m lies to the left of point n, which means that the x coordinate of point m, it must be a smaller number than x coordinate of point n. So therefore, we can conclude from here. Therefore, point m is negative 1, comma, negative half. Point n is 3 over 2, comma, 3 over 4. And that is my solution to question 6.